and welcome to the session Fundamentals of Multimedia. Today we are discussing communication protocol, its types and functions. We are living in the information technology times. The IT provides us many powerful tools that have significantly changed our way of life, work and business operations. Among all the IT advancements, Internet has the most impact in every aspect of our society. To build the Internet and many other networks, engineers and organizations around the world have created many technologies over the past 20 years in which communication protocol is one of the key technological areas. After years of development on the communication standards and generations of networking architecture, network communication protocols have become a very complex subject. Various standard organizations have defined many communication protocols and all major vendors have their own proprietary technologies. Yet, people in the industry are continuously proposing and designing new protocols to address new problems in network communications. It has become a huge challenge for IT professionals at all levels to understand the overall picture of communication protocols and to keep up with the pace of its ongoing evolutions. So, what are protocols? When two humans converse, they may have to use the same language, but they generally understand each other without having to adhere to rigid rules of grammar or formal language frameworks. If computers wish to communicate with one another, they have to know in advance exactly how information is to be exchanged and precisely what the format will be. Therefore, standard methods of transmitting and processing various kinds of information are used, and these methods are called protocols. Protocols are established by international agreement and ensure that computers everywhere can talk to one another. There are a variety of protocols for different kinds of information and functions. These are referred to as protocols, and some of the most common ones such as TCP, IP, UDP, POP, SMTP, HTTP, FTP, SNMP, Gopher, Telnet, etc. This session will discuss some of the common protocols that the average PC user is likely to encounter. TCP/IP. Transmission Control Protocol and Internet Protocol are two different procedures that are often linked together. The linking of several protocols is common since the functions of different protocols can be complementary so that together they carry out some complete task. The combination of several protocols to carry out a particular task is often called a stack because it has layers of operations. In fact, the term TCP/IP is normally used to refer to a whole suite of protocols, each with different functions. This suite of protocols is what carries out the basic operations of the web. TCP/IP is also used on many local area networks. Here, we will briefly describe some of the basics of this very important group of protocols. When information is sent over the Internet, it is generally broken up into smaller pieces or packets. The use of packets facilitates speedy transmission since different parts of a message can be sent by different routes and then reassembled at the destination. It is also a safety measure to minimize the chances of losing information in the transmission process. TCP is the means for creating the packets, putting them back together in the correct order at the end, and checking to make sure that no packets got lost in transmission. If necessary, TCP will request that a packet be resent. Internet Protocol or IP is the method used to route information to the proper address. Every computer on the Internet has to have its own unique address known as the IP address. Every packet sent will contain an IP address showing where it is supposed to go. A packet may go through a number of computer routers before arriving at its final destination, and IP controls the process of getting everything to the designated computer. Remember, IP does not make physical connections between computers but relies on TCP for this function. IP is also used in conjunction with other protocols that create connections. Next is UDP and ICMP. Another member of the TCP IP suite is User Datagram Protocol or UDP. A datagram is almost the same as a packet, except that sometimes a packet will contain more than one datagram. This protocol is used together with IP when small amounts of information are involved. It is simpler than TCP and lacks the flow control and error recovery functions of TCP. UDP uses simple connectionless transmission on model with a minimum of protocol mechanism. It has no handshaking dialogues and thus exposes the user's program to any unreliability of the underlying network protocol. There is no guarantee of delivery, ordering or duplicate protection. UDP provides checksums for data integrity and port numbers for addressing different functions at the source and destination of the datagram. A different type of protocol is Internet Control Message Protocol or ICMP. It defines a small number of messages used for diagnostic and management purposes. Next is Mail Protocols POP3 and SMTP. Email requires its own set of protocols and there are varieties both for sending and receiving mail. The most common protocol for sending mail is Simple Mail Transfer Protocol SMTP. When configuring email clients, an internet address for an SMTP server must be entered. The most common protocol used by PCs for receiving mail is Post Office Protocol or POP. It is now in version 3, so it is called POP3. Email clients require an address for a POP3 server before they can read mail. The SMTP and POP3 servers may or may not be the same address. Both SMTP and POP3 use TCP for managing the transmission and delivery of mail across the internet. Next is IMAP or Interactive Mail Access Protocol. A more powerful protocol for reading mail is Interactive Mail Access Protocol or IMAP. This protocol allows for the reading of individual mailboxes at a single account and is more common in business environments. IMAP also uses TCP to manage the actual transmission of mail. Next is Hypertext Transfer Protocol or HTTP. Web pages are constructed according to a standard method called Hypertext Markup Language or HTML. An HTML page is transmitted over the web in a standard way and format known as Hypertext Transfer Protocol. This protocol uses TCP IP to manage the web transmission. A related protocol is Hypertext Transfer Protocol over Secure Socket Layer or HTTPS. First introduced by Netscape. It provides for the transmission in encrypted form to provide security for sensitive data. A web page using this protocol will have HTTPS : at the front of its URL. HTTP is also used as a generic protocol for communication between user agents and proxies or gateways to other internet protocols such as SMTP, NNTP, FTP, Gopher and WAIS, allowing basic hypermedia access to resources available from diverse applications and simplifying the implementation of user agents. Next is HTTPS. HTTPS is a protocol for network security over a computer network which is widely used on the internet. HTTPS consists of communication over Hypertext Transfer Protocol within a connection encrypted by Transport Layer Security or its predecessor Secure Sockets Layer or SSL. The main motivation for HTTPS is authentication of the visited website and protection of the privacy and integrity of the exchange data. In its popular deployment on the internet, HTTPS provides authentication of the website and associated web server with which one is communicating, which protects against man-in-the-middle attacks. Additionally, it provides bidirectional encryption of communications between a client and a server, which protects against eavesdropping and tampering with or forging the contents of the communication. In practice, this provides a reasonable guarantee that one is communicating with precisely the website that one intended to communicate with, as opposed to an imposter, as well as ensuring that the contents of the communications between the user and site cannot be read or forged by any third party. Next is SHTTP, Secure Hypertext Transfer Protocol. Secure Hypertext Transfer Protocol is an obsolete alternative to the HTTPS protocol for encrypting web communications carried over HTTP. Secure HTTP is a secure message-oriented communication protocol designed for use in conjunction with HTTP. Secure HTTP provides a variety of security mechanisms to HTTP clients and servers, providing the security service options appropriate to the wide range of potential end users possible for the World Wide Web, WWW. Secure HTTP provides symmetric capabilities to both client and server in that equal treatment is given to both requests and replies as well as for the preferences of both parties, while preserving the transaction model and implementation characteristics of HTTP. Next is File Transfer Protocol. File Transfer Protocol, FTP, lives up to its name and provides a method for copying files over a network from one computer to another. More generally, it provides for some simple file management on the contents of a remote computer. It's an old protocol and is used less than it was before the World Wide Web came along. Today, its primary use is uploading files to a website. It can also be used for downloading from the web, but more often downloading is done via HTTP. Sites that have a lot of downloading, like software sites for example, will often have a file transfer protocol server to handle the traffic. If FTP is involved, the URL will have FTP : at the front. The key functions of FTP are: number 1, to promote sharing of files, that is computer programs and/or data. Number 2, to encourage indirect or implicit via programs use of remote computers. Number 3, to shield a user from variations in file storage and systems among hosts. And number 4, to transfer data reliably and efficiently. Next is DHCP, Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol, DHCP, is a communications protocol enabling network administrators manage centrally and to automate the assignment of IP addresses in a network. In an IP network, each device connecting to the internet needs a unique IP address. DHCP lets a network administrator supervise and distribute IP addresses from a central point and automatically sends a new IP address when a computer is plugged into a different place in the network. DHCP uses the concept of a lease or amount of time that a given IP address will be valid for a computer. The lease time can vary depending on how long a user is likely to require the internet connection at a particular location. It's especially useful in education and other environments where users change frequently. Using very short leases, DHCP can dynamically reconfigure networks in which there are more computers than there are available IP addresses. DHCP supports static addresses for computers containing web servers that need a permanent IP address. Next is IRCP, Internet Relay Chat Protocol. Internet Relay Chat Protocol, IRCP, which is well suited for running on many machines in a distributed fashion, enables teleconferencing on the internet. The IRC protocol has been developed on systems using the TCP/IP network protocol, although there is no requirement that this remain the only environment in which it operates. The IRC protocol is a text-based protocol with the simplest client being any socket program capable of connecting to the server. Next, we look at NNTP, that is Network News Transfer Protocol. Network News Transfer Protocol (NNTP) specifies a protocol for the distribution, inquiry, retrieval and posting of news articles using a reliable stream such as TCP port 119 server client model. NNTP is designed so that news articles need only be stored on one presumably central server host, and subscribers on other hosts attached to the network may read news articles using stream connections to the news host. The Network News Transfer Protocol (NNTP) established the technical foundation for the widely used news groups. NNTP is modeled after the Usenet news system. However, NNTP makes few demands upon the structure, content or storage of news and articles, and thus it can easily be adapted to the other non-Usenet news systems. Using NNTP, hosts exchanging news articles have an interactive mechanism for deciding which articles are to be transmitted. Next, we look at SLP, that is Service Location Protocol. The Service Location Protocol (SLP) provides a scalable framework for the discovery and selection of network services. Using this protocol, computers using the internet no longer need so much static configuration for network services for network-based applications. This is especially important as computers become more portable and users less tolerant or less able to fulfill the demands of network system administration. Next is SNMP, or Simple Network Management Protocol. SNMP, an application layer protocol, is the standard protocol developed to manage nodes, servers, workstations, routers, switches and hubs, etc. on an IP network. SNMP enables network administrators to manage network performance, find and solve network problems and plan for network growth. Network managed systems learn of problems by receiving traps or change notices from network devices implementing SNMP. IPv6, Internet Protocol version 6, at this point of discussion is the most recent version of the Internet Protocol, the communications protocol that provides an identification and location system for computers on networks and routes traffic across the Internet. IP version 6 was developed by the Internet Engineering Task Force (IETF) to deal with the long anticipated problem of IP version 4 address exhaustion. IP version 6 is intended to replace IP version 4. Next is SNTP, Simple Network Time Protocol. The Simple Network Time Protocol SNTP version 4 is an adaptation of the Network Time Protocol NTP used to synchronize computer clocks in the Internet. SNTP can be used when the ultimate performance of the full NTP implementation is not needed or justified. Next is TFTP, Trivial File Transfer Protocol. Trivial File Transfer Protocol is a simple protocol to transfer files. It has been implemented on top of the Internet User Datagram Protocol (UDP). TFTP is designed to be small and easy to implement and therefore lacks most of the features of a regular FTP. TFTP only reads and writes files or mail from or to a remote server. It cannot list directories and currently has no provisions for user authentication. Next is RDP, Reliable Data Protocol. RDP is a connection-oriented transport protocol designed to efficiently support the bulk transfer of data for such host monitoring and control applications as loading or dumping and remote debugging. It attempts to provide only those services necessary in order to be efficient in operation and small in size. Next is RIP, Routing Information Protocol. Routing Information Protocol is a standard for exchange of routing information among gateways and hosts. This protocol is most useful as an interior gateway protocol. In a nationwide network such as the current internet, there are many routing protocols used for the whole network. The network will be organized as a collection of autonomous systems. Each autonomous system will have its own routing technology, which may well be different for different autonomous systems. Next is Gopher. Gopher offers downloadable files with some content description to make it easier to find the file you need. The files are arranged on the remote computer in a hierarchical manner, much like the files on your computer's hard drive are arranged. This protocol isn't widely used anymore, but you can still find some operational Gopher sites. Next is Telnet. You can connect to and use a remote computer program by using the Telnet protocol. Generally, you would Telnet into a specific application housed on a serving computer that would allow you to use that application as if it were on your own computer. Again, using this protocol requires special software. Now, let's look at the summary of this session. Having completed this session, you would now be able to identify the properties of Internet Protocol, describe an IP address and relate TCP and UDP protocols to IP. While the age-old concept of the network is foundational in virtually all areas of society, computer networks and protocols have forever changed the ways humans will work, play and communicate, forging powerfully into areas of our lives that no one had expected. Digital networking is further empowering us for the future. New protocols and standards will emerge, new applications will be conceived, and our lives will be further changed and enhanced. While the new will only be better, the majority of digital networking's current technologies are not cutting edge, but rather are protocols and standards conceived at the dawn of the digital networking age that have stood solid for over 30 years. Now, there are a few assignments for you to work out. The first question is, describe why does every device need an IP address? Second question, discuss in detail various Internet protocols and their characteristics. Third, enumerate the role of IP in TCP/IP suite. Fourth, what is IP version 6 and how is it different from IP version 4? Fifth, explain the role of communication protocol in the age of information and communication technologies. I can suggest you some references and web links for this session. A Protocol for Packet Network Intercommunication by vSurf, published in 1974 by Jeremy Norman and Company. 2. Advanced Communication Protocol Technologies, Solutions, Methods and Applications, published in 2011 by Tarney K. Adamus, G. and Dulai T. by IGI Global. 3. The Design Philosophy of the DARPA Internet Protocols, written by Clark D., published in 1988 by MIT. 4. Data Communications and Networks, written by Godbole A.S., published in 2002 by Tata McGraw-Hill Education. 5. Network Protocols Handbook, published by Javvin Technologies Inc. 2005. 6. Introduction to Basics of Communication Protocol, written by Venkataraman PP in 2011. Web links: www.webopedia.com. Next, www.tutorialspoint.com. Hope this session was useful for you. Thank you for watching this. Bye.